In college algebra, we wrapped up graphing rational functions. We left off after finding vertical asymptotes, and now we are working on horizontal. So there are three scenarios we need to account for. These are not steps, so in your notes just write scenarios. You need to match which one goes with the problem that's typed. So for example, if we have something like this, let's use a different front number. That'd be confusing. So if we have something like this right there is the degree of the numerator, which is, we're going to call n for the horizontal asymptotes. And this is the degree of the denominator. So this fits with scenario 1 because n is less than m. So that means you have a horizontal asymptote at 0. We may get a function that looks something like this. And this one is still in. This one is m. And they're equal to each other. So in this case, you need to get the coefficients. The lead coefficients for the numerator, that's an. This is the lead coefficient for the denominator. And those tell you what your horizontal asymptote is. So you write y equals 4 over 5, and you reduce if you can, but you can't on this one. So that is your horizontal asymptote. Scenario 3 is the easiest. What if we have something like this? Then that is n, this is m, and we see that n is greater than m, no horizontal asymptote. All right, so let's give it a shot. We have number 5 here with 3 different examples. Maybe hit pause if you feel like you have the hang of it. This one we know n is 1 because there is a 1 right there. And we know m is 2, that 2 right there. So n is less than m. This is the first scenario. Y equals 0 is our horizontal asymptote. Let's try another one. N is 2, m is 2, they equal each other. So that's scenario 2. We need to write down the coefficients. I know the front number up top is 4, and the front number on the bottom is a 2. So when I put those into an equation over each other, I can reduce it down to 2. So that means I have a horizontal asymptote at y equals 2. Part C, n is 3. All right, I had to hit pause. I don't remember my last word, but n is 3, m is 2, n is greater than m, so no horizontal asymptote. Meant to change colors on that one. It's all red. All right. What we're going to do now is dive into graphing a full rational function. And I'm going to change this up over here. We're going to skip this step. I mean, it is somewhat useful, but at the same time, I feel like it kind of takes care of itself. So we're going to do 5 steps. All of these steps should be familiar to you. We haven't ever talked about step 2 and how to do that with a rational function, but it's pretty simple. You just do what I typed in the parenthesis. And step 5, we're just plugging in points once we have all those bounds, all those asymptotes. So step 5 is very much like 7th grade math. We're just plugging in values. All right? So let's give it a try with number 6. And what we do is step 1, I like to write down what we're finding. And we're going to plug in 0. And it works out pretty nice. We get 0. So make a dot on 0 on the origin. Pretty similar for the x-intercept on this problem. It's not always like this, but in this case it is. So if you look at the top of the page, it says set the numerator equal to 0 and solve. So when we solve that, we get 0 again. You still have to write it, but the dot is already made. Step 3 is vertical asymptotes. And we did that earlier in this handout. So you set the denominator equal to 0, and you solve. So we get 1. You make a dotted line vertically through 1. Horizontal asymptotes, that's the new thing today. And for our problem here, it looks like n is 1, because it's 2x to the first power. M is also 1. Our coefficients, since n equals m, that's scenario 2. Our coefficients are 2 and 1. So that means we have a horizontal asymptote at 2. So we want to draw a horizontal line through 2. All right, step 5 we have yet to do together. What I do is I make a table and I write down values left and right of the vertical asymptotes. So it's a good rule of thumb to maybe do 2 points per zone. So for example, this is a zone and this is a zone. Those are my own words there, that's not technical. So I want 2 points left of that line, 2 points right. I already have 1 point left, so let's plug in -1. And to the right of that line, let's plug in 2 and 3 and see what we get. When I plug in -1, I get 1. When I plug in 2, I get 4. And lastly, when I plug in 3, I get 3. So we have a dot right here. We have one right here and one right here. And we draw our graph. Usually they're going to look like parabolas. Like that. And like that. All right. Let's do one more. All right, I'm going to pick up the pace a little bit. Step 1 is the y-intercept. Plug in 0. And we get 0. Make a dot on the origin. Step 2 is the x-intercept. I need to write smaller because I may run out of room on this one. When we set the numerator equal to 0, we get 0. But we already have a dot there. Step 3, vertical asymptotes. A touch more involved this time. We set the denominator equal to 0 and solve. So let's factor. And this time we get 2 vertical asymptotes. So I need vertical lines at 2 and -2. My horizontal asymptote, thought I was going to write smaller. I'm running out of room here. N is 2, M is 2. They're equal, that's scenario 2. So I take my 2 lead coefficients and I put them over each other and we just get 3. So I need a horizontal line at 3. All right, we have 3 zones. We have a zone here, a zone here, and a zone here to plug in points for step 5. So in step 5, I'm looking at those zones and I'm going to plug in -4 and -3. The middle zone, sometimes it behaves weird. So I'm actually going to plug in 2 more points around that existing purple point so I can be sure how it behaves. And then 3 and 4 to the right. So when I plug in -4, I'm going to get a big number up top, I believe. I get 48 over 12, which is 4. Let's plug in -3. I think I get a decimal on this one. Yep. We get 5.4. Running out of room. Let's plug in -1. And I get 3 over -3. I get -1. Plug in 1, and I bet I'm going to get -1 again. Yep. Plug in 3, and I bet I'm going to get 5.4 again. Because this thing is symmetric. And yeah, 5.4, 27 over 5. Last one, I bet I get 4. Sorry, I'm running out of room here. Uh, 48 over 12 is 4. All right, let's plot these points. So we have a graph here. This one's like a little mini parabola. and then another one here. All right, that was a big problem. Hope it made sense. See y'all later. Bye.